Hello, this is the video for Chapter 6, Lesson 8. It is the last lesson of Chapter 6. And in this lesson, we're going to combine what we learned in Chapter 5 with everything we've done in Chapter 6 so far. So in this lesson, it's called the System of Linear Inequalities. So basically, we have a system of inequalities, meaning two or more inequalities. Well, we're going to look at what this looks like when we graph and how to find the part in which the systems are overlapping or connected and related. So let's read our objective here: to solve systems of linear inequalities by graphing and to model real-world situations using systems of linear inequalities. The graph of a system of linear inequalities in the region where the graphs of the individual inequalities overlap. So let's just jump to it and talk about, first of all, what our graphs would look like. If we're looking at this example here, our first inequality, remember, I'm really just going to read it as a y equals mx plus b type of equation. And right here, our negative x is basically negative 1x. And so our slope is negative 1 over 1. So I would write the slope out on the side and then draw these arrows. It's going down 1 to the right 1, meaning I have a y-intercept at 5, and then it's going down 1 to the right 1. So be very careful with these negative slopes, because I've noticed some of you guys, when you see a negative, you just make both numbers, numerator and denominator, negative. But the reality is that negative only is lumped in with either a numerator or a denominator, because remember, if you have a negative over a negative, it turns it into a positive. Okay, looking at our next equation, we can't graph this just yet because it is not in the form of y equals mx plus b. So I'm going to add 3x on both sides and get y by itself. This now becomes y is less than or equal to 3x minus 4. I'm going to put the 3x in front, so it's in the form of y equals mx plus b. I'm going to put my intercept at negative 4, and the slope here is 3 over 1. So if you want to put on the side 3 over 1, going up 3 over 1. So I'm going to do that. Up 3 to 3 over 1, up 3 over 1, up 3 over 1. And I'm going to graph my line. I would recommend getting a straight edge and connecting everything. And now we have to talk about shading and what that looks like. All right. So I tend to graph my lines first and then go back and look through everything. So now I'm going to check my inequalities and decide if it's a greater than or less than symbol, and if it's a greater than or equal to or less than or equal to. Because remember, if it's also includes the equal to, I have a solid line. So it's what's nice here is these lines are solid, so I don't have to make them dotted. And then I'm going to shade. So my first equation is y is greater than or equal to. And so if you remember, when you have greater than or equal to, or just greater, it is going to be shading to the right or above, okay? And then when you have less than or equal to or less than, it's going to be shading to the left or below. So if you can remember what these inequalities indicate in shading, you don't have to figure out a test point. You don't have to use a test point. So what I'm going to do is I'm going to look at my first equation, and I'm going to shade the direction that that line to the direction left or right or above or below of that line. So my first equation is this line right here, and it is greater than or equal to. So I'm going to shade above. This whole section is what's shaded for that first equation. And then my second equation, is less than or equal to, meaning I'm going to shade below. And so uh, I'm going to shade below the line, which will be right here. And if you're ever not sure, you can always pick a test point to double check your equation by plugging in, like 0, 0 or something like that to see if you're shading to the left or right of that. And so now that I've shaded both individual lines, remember this is kind of what we did in chapter 5, then I'm going to look at where they overlap. And where they overlap is what they have in common. So everything in this little section here where I'm kind of drawing my lines or I'm shading with the pink is the possible solutions for both equations. Okay, so let's look at if we're given a graph and we have to come up with our own equations. So the first thing I would do if I were you is look at your lines and just write it as a linear equation first, and then go back in and figure out your inequalities and all that. So my line, that's solid right here. It has a y-intercept of 1. So I'm going to put it as +1. And then I'm going to look at the slope. So if I pick a point here, it looks like it's going up 1 over 2. So that would be up 1 to the right 2, which is 1/2 x. Okay, so if this was just a line, it would be y equals 1/2 x plus 1. Now, it's a solid line, so I know that whatever inequality it is, it's going to have an equal to or equal to part to the inequality. And then it's shading below, which means it's going to be a less than symbol. Okay, so looking back above at this little chart that we wrote down, and you did this in your chapter 5 notes, but we can put it here as well. That is going to be y is less than or equal to y, y is less than or equal to 1/2 x plus 1. And so if we wanted to pick a test point just to double check to see if that's true, we could put 0, 0. 0 is less than or equal to 1, and that's true. So that is the equation. Now our next equation is dotted, and so it's not going to have this or equal to symbol to it. But let's just write the linear equation first on the side. It's also at an intercept of 1, so it's +1. And then this time it's going down 1 to the right 2. So it's -1 over 2 because it's going down. So down 1 to the right 2, which means it's -1/2 x plus 1. And it is also, we're shading to the left or below. And so in this case, it looks like it is also a less than symbol. And so it's y is less than -1/2 x plus 1. And those are 2 equations. And that's all you have to do. So all you're doing is just translating the graph into the equation. All right, we've got a question here. Is the point where the boundary lines intersect a solution of the system? So question is this point, this +1 on the y-axis, or the 0, we would say 0, 1, as a point, a solution? So you can check to see if it's a solution by plugging in your variables and put them into your equation. However, if you were to plug that in, you would realize that it is not a solution for this equation because this equation does not have an equal symbol right below. And so it makes it so that that whatever is, if it's a point on the line, it's not a solution for y is less than -1/2 x plus 1. So we could say no, because the dotted line means it's not a solution. So whatever's on the dotted line is not actually a solution for the equation. Now, if they were both solid, then yes, it would be. Okay, next one. Let's practice graphing. So over here, we've got y-intercept of +2. And if I'm looking ahead, this inequality does not include an equal. So whatever line I pick or draw, it's going to have to be a dotted line. And then it's a slope of 2/1. So up 2/1, up 2/1. And I'm going to make it dotted. And then I'm going to use black for my next one. -3 is my y-intercept. And it is a slope of -1/1. So -1/1. And this one will be a solid line. Excuse me. Let me connect it the best I can. Try for me to graph it on this little writing pad that I have. And then let's shade. So I'm going to use my highlighter here. If you guys want to use like a highlighter, two different color highlighters to shade, you're more than welcome to do that as well. So the first equation is y is less than, meaning I'm going to shade to the left or below. So here, I know it feels confusing because it's like this side is the left, but this side is below the line. Okay. So that's the first equation. And then the second one is greater than or equal to, meaning it's going to be above. So for this one, it's going to be above or to the right. So it's above here. And where are they overlapping? They're overlapping right here. Now, if I pick different colors, you might be able to see it better. Maybe I'll pick like blue or something, and then, you know, yellow and blue would make green. So we could see what this next one looks like. Okay, B, graph it, +1 up here. Slope here, I'm just going to write it out to the side as -3/1. So down 3 to the right 1. And it's going to be a solid line because I've got this greater than or equal to. So down 3 to 3/1. And make my solid line. Looks like that. Next one, I have -3x -2. So -2 right here. And it's also going down 3/1. And what do you see? Looks like you've got some parallel lines. So they actually do not intersect. Now, let's shade. So for our first equation, it says greater than or equal to, so to the right. And that's over here. The next one, I'm going to shade with blue. And it's less than or equal to. So it's actually going to be to the left or below. And what I see is they do not overlap at all. They're actually going in totally opposite, shading in opposite direction. So this is what we call a no solution. There's nothing in common. And their inequalities do not indicate that anything will overlap. So this is a no solution. All right, C. We've got a y is less than 6. Now, anytime, remember when we saw these equations, y equals 6, that means it's intersecting at 6 on your y-axis. And the only way, so to process through this, the only way you can clearly intersect at 6 on the y-axis is if it's a horizontal line. Remember, we've talked about this. If it's a vertical line, it would intersect at every single number on your y-axis. And so you would not call it y equals that specific number. I'm going to make it a dotted line because it does not include the equal symbol. My next equation, it's a positive intercept at positive 3 on the y, and going up 1 over 1, and also dotted. So now I can shade. Y is less than 6. So that is going to be below, meaning everything down here. And then y is greater than x plus 3. So it is above or to the right, and this is showing above. So I'm going to shade above. And the area in which they intercept is this little section right here. Okay, last one. Problem with these is we've got to reformat them because they are not in the right format. So our first one, let's subtract 3x on both sides. And we are left with negative y is greater than or equal to negative 3x minus 1. Divide by negative 1. Now remember, when you're dividing by negative 1, we've got to flip the inequality. So now this becomes 3x plus 1. Okay, this is the first equation. The second equation, I'm going to do in black. I'm going to subtract 2x on both sides. When I do that, I have y is greater than or equal to negative 2x plus 5. This is my second equation. I'm going to graph. So let's go ahead and graph. Positive 1, I'm going to use pink for my first equation. Positive 1, up 3 over 1. Go the opposite direction. And it is a solid line. Then my second one is also a solid line. Positive 5 and down 2 over 1. Okay. So this is my line right here. Use a straight edge. Then I'm going to shade. So y is less than or equal to, meaning to the left or below. And this would be below down here. Whenever you're not sure, go ahead and pick a test point. I know these less than or below ones are kind of weird, or left or below ones are kind of weird because you want to shade to the left, but technically, I guess below overrides to the left. Y is greater than or equal to the black equation, meaning above or to the right. That's over here. So where they intersect is this little section right here. And there you go. That's all we're doing for this lesson. So it's bringing everything together. It's just going to take practice and remembering how to shade. All right, that's all I have.